Welcome to the Upkeep Pledge Pros podcast, a podcast dedicated to unmatched value and unwavering support for our community and our customers. Today, we have returning my friend, Upkeep Ambassador, Dr. Howard Penrose of MotorDoc. Howard, welcome.
Hey, good morning, I think.
Yeah, no, it's kind of the late morning for you and I.
Yeah.
So Howard's back. Howard is a hard guy to drill down. You all know that. He's constantly moving and shaking. And doing some serious business in our world of maintenance and reliability, particularly in energy, in motors, and wind, and infrastructure, all these awesome things. And I had to get Howard back on because there's two things that I wanted to talk about. One is root cause analysis with motors, generators. Howard does that every week. He's going into places that are secret, government, large corporations, state, all these things, and figuring out what's happening with their power generation, their large motors. And then the other thing I wanted to talk about today is a little bit about wind. Wind is a very renewable, very crucial thing now that's coming up a lot. They're talking about putting wind farms in the ocean, on the shores. They're all over the Midwest. And I think there's a lot that people don't understand about them, even myself. And I wanted to talk about that and their connection to your house, your facility, how all that works, right? And what's in between them, the infrastructure between them. So, Howard, I wanted to kick it off. Let's talk a little bit about don't get into details, some of your recent root cause analysis with some motors and generators and how you kind of pick those apart when you get the phone call, hey, I've got a broken thing and I needed to understand why it broke.
Okay. I've got two very recent last 2 weeks, and actually the transition can be between this and the wind energy thing can be the work we do with the wind industry overall.
Right.
That has to do with RCFA. A lot of the OEMs and owners and actually national labs get us involved in large, we'll just say RCA projects having to do grid all the way down to generation. So we can use that as a little bit of a transition, I think.
Awesome.
Yeah, I think a lot of times when I get involved in RCFAs, and we talk about this a lot in industry, I have one rule, and that rule is something I was taught through, I've always followed the PROACT process, right? And the old reliability group and all that stuff, and they're all the same.
That's our friend Bob Latino, right?
Exactly.
Good friend, and also Upkeep
Bob
Ambassador.
and Ken, and of course, they sent me a copy of the book that their father had written and stuff.
They are the best. They're awesome guys.
Oh yeah. And I think their company is now called Prelical.
Prelical. Yeah, if you talk to Bob, he's always like, "Why do we call ourselves that?"
I'll have to ask him.
Yeah, it's funny.
I'm still trying to get the pronunciation down.
They're awesome.
But anyways, so part of that whole process is the understanding. Now I have to look at these every single time, and I've had to go to as an expert witness in court cases and stuff like that based upon our CFAs.
Right.
So I have to treat it every time. And when I do teach the courses related to RCFAs, I'll usually put that as something generic. I always say the same thing. Data's king. Interviews mean nothing. I cannot go in with an opinion. I can't go in with something else. Some of the ones we've had recently emphasize that. I had something that's been coming up a lot recently is, a little is good, more is better. People forget that electrical systems, insulation systems, and so on keep advancing. So you can go thinner and thinner. And then I'll hear comments, they're going thinner, trying to save money. No, they're trying to do heat transfer.
Right.
So I'll go into situations where, there's supposed to be, I'll give that example, 36 thousandths worth of insulation. Instead, there's a 1/4 inch, right?
We need to move heat.
We need to move heat. And those systems are literally thermal blankets.
Right.
So I've run into this multiple times. And I can say that because with the ones that I've done over the last couple of months, nobody knows which one I'm talking about.
Right. There's a lot of them.
There's a lot of them. going in, I'll do things like ask for information. Everybody goes, why do you need that information? That has nothing to do with this little spot right here that failed. And I'm trying to explain that little spot is the fuse that blew.
Right.
There's something that blew that fuse, and we're trying to find it. So in a couple of cases, I get complete data, like we'll say a generator. I went back and I said, okay, what type of system are you using for the excitation system for the salient pole generator? They tell me, and I say, well, here's the data I need. They send me all the data, so I know all the power output, the harmonic content, the excitation, um, the ripple in the excitation, which will tell me, if I hit 10%, then I know I have a bad diode, that
Right.
kind of thing. I get all that data together. And then I might go outside and get temperature data for the local area, figure out where the system is located. Things that seem anomalous at first, but always seem to come together, especially when somebody goes, well, this was happening with the generator. And you look at the data and you go, no, it's not what was happening. It was running perfectly the
It's the
same that
switch
whole
gear.
time. Right. Yeah, exactly. It's
Yep.
like, yeah, I mean, the data tells everything. And if you get enough data, you can do it. As a matter of fact, before we got on this call, I'm doing the same thing for a wind site with all the data that they provided. And, everybody, well, data science. Well, I've always done this. I had to do
Yeah.
it in Excel spreadsheets before. Now I get to use more powerful tools. So, but going in, it's like, okay, first thing I do is I say, here are the problems, and I'll list the problems, possible and improbable, right? What did Sherlock Holmes
Yeah.
always
Their
say? If you
likelihoods, right?
eliminate the
What's likely?
possible or whatever, the improbable, no matter how unrealistic, is probably it.
Yep.
Um, I had a case like that with the Navy back in around 2011 or 12.
I was
We
still in the Navy then, Howard.
Yeah, you youngsters. Uh, so, so in any case, I do a lot with carriers on occasion. As a matter of fact, next week we'll be involved in something.
Nice.
Um, and when we looked at information having to do with oil coming through a motor, uh, we and the motors had just been repaired and everything rebuilt to spec, right? For very critical machines, um, going into gearboxes. And when we got the stuff in, the last thing I put down on the RCFA beginning tree was oil compatibility. And everybody told me, well, that material is compatible with everything. And I go, okay, the seal material is compatible with everything. So we found the seal had failed. So we're looking at fits and we're looking at this and that and everything else. And I asked for the tear sheet on that oil. So it took forever, and I finally get the tear sheet. Now they had changed all of the gaskets and the gearboxes and everything else to this particular material. And I'm looking at the tear sheet from the oil man, from the oil producer, and it goes, you can use this type of seal, and whatever you do, don't use Viton.
I was just about to say that, Howard. There's a reason that they have Viton, Buna N, rubber,
Yes.
nylon, glass, PTFE, like all these things because they have compatibility, speed, temperature
Yeah.
requirements.
Yeah. So the Viton seal it cost about $32. It was cheap. The seal that we found actually worked with it was 48 cents.
What was that? Was it Buna N?
Yeah, exactly. And it just so happened that seal material was perfectly compatible with that oil.
Right.
But all of this particular class of vessel had the same problem as a direct result because they normalized on a specific oil, which is fine. That makes sense. But somebody somewhere along the way missed that part of the tear sheet.
Yeah.
And we dug further, it turns out to be a salesman.
Yeah, they shouldn't be making any of those decisions.
Oh yeah, yeah. Well, I just had another one recently on the roof of a. I actually made a comment. Those who follow me on LinkedIn, and I believe either the VP or CEO of ITW, the Impro. I'm sorry, not Impro. Aegis is has put a blog together and had me review it before he posts it. I basically went up and we're doing an RCFA and all the on a motors on for a data center for the chillers.
Right.
And it's like when they lose a couple of chillers, they're in trouble.
There's a lot of waste heat in there.
Yeah, a tremendous amount. It's 90% of the cost that goes into a data center versus cryptocurrency. That's like nothing.
Yeah.
But into a data center goes into chillers, fans, pumps, things like that to cool off the system. As a matter of fact, you go into a gigantic building and it's all the cooling systems necessary for one room worth of, servers. So we go up there and I take a look at it, and then I look at all the reports, and they're all identifying all these other things. And I realized that somebody had selected the wrong IP rating. They selected an IP55 instead of an IP65, and they put them vertical. Now, it would have been perfectly good, except they were exposed.
Right.
So underneath a fan that cools a motor, right underneath, you draw a vacuum, just like in a pump.
Yep.
And so they were drawing rain up underneath, and then it would go straight down the shaft into the bearing.
It's like a Venturi effect.
Exactly. And so I go back and I'm like, you're getting water in your grease. And the response was, well, it's shaft currents. And I go, yeah, but the
water conducts
in the
electricity.
motor shaft, it's a JM shaft, extend into, coolant fluid. Anyways, which is basically a shaft brush.
Right. It's a conductor.
Exactly. And it's like not water, it's almost pure coolant. And it's like,
Right.
And so I'm explaining this online. It's like it's extended into this material. It's like, but every motor on a drive needs a shaft brush. It's like, no. That's not the case. They all don't fail from shaft currents. Now, mind you, we're seeing a rapid increase in that, which will come up when we talk about the wind turbine RCFAs.
Right.
But
So you get back, you're asking for this very specific data.
Yeah. So specific data, start the tree, determine what could cause each of those conditions. So you're building an actual tree.
Correct.
This is not a 5Y. It's
No.
not a fishbone analysis. None of that stuff. And ProX isn't the only one that takes this approach. There's multiples of them.
Are you using the ProAct software?
I'm using the old one. I have an
Okay.
old laptop I still use.
Yeah.
You can actually do the one online.
Yep.
But I don't use it often enough for the license fee.
Right. Bob gave me access to it to play around with one day.
I did initially too. It's phenomenal.
It's phenomenal.
If you're doing RCFAs all the time, you definitely want that.
Yes.
I'm in the process of considering switching back over to it, but I still use the original version because I still have a licensed copy.
Nice.
So until that laptop finally fails.
Well, it's older. It might not die as quick as you think.
Yeah. What about Windows 95? No. So anyways,
you're building out the trees.
So I build out the trees, and for each thing, I have to either identify that there's data that says, nope, that can't possibly it. So identify a test.
Yep.
And then write everything down and keep all the evidence, either in the software, or I usually do it separately as a file. That could be images, data, whatever. So something saying yes or no.
That's right.
And if I can't, I just leave it open and say, we need this additional data. And you can end an RCFA and have open issues.
Of course. There's
They're
all contributing factors.
Right. And this whole thing with cost and all this other stuff built into the RCFA. And I will usually just ignore that stuff, because usually if I'm called into an RCFA, it's not a little one.
Yeah, it's expensive.
And the cost isn't an issue. In this case, whole plant down, for weeks.
Yeah, what does that mean?
Okay. Whatever the cost is, don't worry about it. And it's like, and we're throwing around 6-7 digit numbers and stuff like that. Right. So, sometimes larger.
Right.
So in any case, so go down through it and come up with all that stuff, because I need that evidence. I need an ironclad finding when I'm done. You never get one, but that's the goal.
Yeah.
Right?
You get all the contributing factors, right? You get a picture, an understanding.
Even when things are obvious, and you also have to have input from everybody. And there'll be contentious people in there because they're protecting themselves, their company. They
100%.
don't want to pay a warranty. They didn't get the insurance company involved. You know,
Correct.
whatever the cases are, they're constantly trying to throw in,
They
you
got
know,
skin in the game.
oh yes. So you'll often get somebody who'll say, okay, well, that could be caused by this, this, and this. Okay, we'll add it to the tree.
Right.
Add it to the tree, and then you show why it is or is not.
Right. That's
And
why
the key thing,
facilitators are so important.
exactly, keeping an open mind.
Yep.
And I'll often say, regardless who I go in with, and that's part of the reason we're brought in, is my and our reputation is I don't care. I
Yeah, you
don't
have
I
no
don't have I don't have a skin in the game one way
right.
or another. And the people who bring, and if I have customers who want to use it to beat somebody up, then they're not my customer.
Right. I mean, and Howard, I would even back in the day, I would even, if I couldn't come to a consensus with my team on something, maybe it's not a huge issue, but it's
Yeah.
something that could be a repeat issue that causes some problems. I'd ask somebody who has no affiliation to it at all.
Yep.
Maybe an operations guy or a safety guy or
Well,
somebody, hey, come look at this and
one
maybe give me
thing
another thing.
one
Right?
thing that I detest in the industry is the suggestion that you should use a facilitator who has no idea what's going on.
Well, of course.
Because that always comes from the consultants who have no idea what's going on,
Yeah.
that want our CFA work,
You
right?
have to understand
You
systems.
have to know whether something's BS or not.
Yes,
Otherwise, you can be led astray.
that's right.
So most of the work we end up doing is related to electrical systems, electromechanical systems, motors, generators. I've done some on switchgear failures that have ended in fatalities, personnel injury stuff, things like that. Things that are going to go south
Right.
fast, but they need somebody who has an understanding of what's going on. Now, I've had cases where we've had somebody who's supposed to be the neutral party, keeping things in order, and I've been their consultant,
Right.
right? So they'll say, okay, I don't understand this, but I'm the facilitator. I need your help. In that case, you're the subject matter expert,
Right.
that's not involved in the investigation. You're just, helping provide information on what could happen. The end result is haven't lost case yet. If to the point where some companies that have seen that another side was bringing me in on the other side, they would just settle. And I think I've had to sit on a stand for that half a dozen times. Every other time it's like, oh, I mean, I had one recently, I can talk about it now, I think. But had to do with machines on natural gas pipelines. I
Okay.
won't mention names, but
Cool.
the suggestion we found that basically the conductors in the 4160-volt systems and any rubber inside the machine, any of them rubberized material inside these particular machines, all of a particular brand, and particular size, all 4,000 volt, were melting from the lubricant. So it didn't meet API, 541, right? So basically we were looking at the investigation. We were actually looking into something else completely different. We had one taken out. We took the lid off after I'd stood next to it it was started several times. And all there is bare lead wire sitting next to each other in a 4160-volt system. And we, of course, had them shut down the entire pipeline to sort out this issue. And in the end, the motor OEM realized the error. It was we'll just say it was counterfeit materials.
Okay.
Okay,
Wrongly sourced materials.
counterfeit. They were labeled one thing and they weren't.
Oh, gotcha. Yeah,
Got
yeah.
it. Yeah. So
That was happening for a while in the bearing industry. Remember a
we
couple
even
years
had
ago?
that happen in the electric vehicle industry.
Yeah.
We had false Nomex being
Yep.
exported. It hit Italy and then it was distributed from there.
Yeah.
They thought they were getting, somebody thought they were getting a lower cost version of Nomex,
Right.
and they had literally a fibrous material that looked like Nomex with saran wrap in between. I'll just call it saran wrap, but it was literally plastic. It broke down at almost above just above room
Yeah,
temperature.
80 degrees.
Yeah, it was incredible. We did the thermal. We were doing all the studies for a life study on these hybrid. Uh, we'll just say hybrid earth movers, and
Oh, I know what you're talking about.
yeah, the big ones,
The big
and
ones.
and it was like we couldn't get 10 hours out of the insulation system in elevated temperature testing, and it's like, why is this happening? Well,
Right.
turns out
Shitty
that's
stuff.
the other reason I know all the people. So I contacted somebody at DuPont that ran the labs, and he goes, that's not our material. So here's how you tell our material versus the other stuff.
Yep. Cha-ching. There you go.
Yep,
So,
exactly.
so you have your trees, you're going through, you're
Yep,
doing your logic, right? Yes, no. Do I
yep,
have
yep.
evidence? Do I have data? Can I confirm these things? Can I not confirm these things? Um, so we'll go, all right. So we'll go from there. So then you talked about interviewing people.
Yeah, you do interview people just to see if there's something missing.
Right.
But I put it like this. The one time I was setting up to do a class, and I walked across the street. I live in a condo, so walked across the street, and there was a car off of our drive that had gone off the edge of the edge of the driveway or the parking lot, and was nose down into an alley behind. It's a 10-foot drop.
Right.
Um, and everybody said, "Oh, such and such happened, or such and such." And we're walking by, everybody saw it, but nobody actually saw it.
Right.
We find out basically somebody had gotten in the vehicle and put it in the wrong position and
Yeah.
drove it off the edge, and it wasn't the person everybody thought it was. They thought
Right.
it was this elderly person who is known to not drive well and to hit things, and instead it was her son, and who had driven it off the edge by accident because he thought he was in reverse, and apparently had switched down to drive because it was a much older vehicle,
Yeah. It's on
and
the
he
stalk.
shifted down and went all the way, right?
Yep.
So he goes off the edge. So, but when I walk by, everybody's like, "Oh, I saw her," and they took her off in an ambulance, which never happened. All these different things are talked about with that. And what had happened, somebody would have heard it from around the corner, ran over and looked, and then in our mind's eye, we attribute all of the things from our past into what happens in that incident.
Sure. What they
So
call that? What they
the
call that?
mind plays tricks.
Yeah. Cognitive dissonance or something like that.
Yeah, yeah,
Yeah.
yes. I think that's actually on the slide.
I think
So,
that's, yeah. I think that's what they
so
call
what ends up happening is we all have our own point of view based upon history and everything else that won't relate to the data.
Sure.
So, and that's why when you interview multiple people, you're going to get different stories. And everybody's the hero, by the way.
Of course.
Everybody solved the problem.
Yep.
And hell, I've been guilty of that. We've all been guilty of it, right?
Hey, I like being a hero from time to time.
Yeah, exactly. So that's another story. But in any case, uh, when we go through these things, that data becomes important. Interviews are there to help guide us
Sure.
to look for which data, something we didn't think about. That's one of the reasons you use a team,
That's
right?
right.
The ones over the last several weeks, the one yesterday in a federal building, that one, there's companies that have, they have representatives with companies that have skin in the game. They've got all these other folks involved, the building owner, the repair company, everybody except the motor OEM,
Right.
right? But they're represented by the package company.
Right.
So everybody's represented. I put, and then I'm putting the RCFA together on, what I think occurred and everything else. So I was down there taking some data from a different standpoint, and everybody else is taking their data. And one of the guys walks up to me and he goes, "So what do you think's wrong?" And I said, "Oh, I solved the problem like 5 minutes after I arrived, but now we just have to get everything together so we can make sure that that's actually what it is." And he goes, "Really? I thought this was an RCFA." I go, "Yes, it's an RCFA. I'm just kidding. I don't know."
You have no idea. I just got
No
here.
idea. I'm being facetious.
Yeah.
I mean, data will tell me some things, and I'll be on site and I'll say, "Oh yeah, it looks like this,"
Right. Of
and
course.
then everybody's like, "Oh well, get me the report." I said, "Yeah, wait, I'm not definite on it yet till I sit down and I look at all the data and the context of the failure."
Big one.
And that's what everybody forgets. Every investigation that I'm brought into that has failed or whatever else, people forget the context,
Yes.
or they'll be given the understanding that my favorite is in repair shops, right? I ran repair shops for ages. I'd go into a motor repair shop and they'd say, "Oh, the failure is it shorted. That's the root cause. That's why it stopped turning,
Yeah.
but that's not the root cause. What
Right.
caused it to short?"
That's
So
right.
again, don't stop at the don't stop at the fuse.
Yeah. And it's funny talking about data and interviewing people. Like I was managing several port cranes for a long time. We
Yeah,
had these very specific four-roped Gottwald crane, German made Gottwald cranes, and they were meant specifically for running big clamshell buckets for discharging the holds of ships and barges.
right.
And you had two center cables that would open and close the grab, and then the two outer cables were holding it. Right, they were for hoisting up and hoisting down. Well, when you would dig a ship, a lot of times the holds were nice and level. But if you were digging a barge, the barges were mounded. So when they would drop that grab, that's why context matters, right? When they would drop that grab onto a mound in a barge, the grab would go like this. It would
Yep.
fall to one side. And if the operator wasn't skilled enough or didn't have enough experience in that context, he would create a slacked rope alarm. The crane would go, "I have a slacked rope,
Yep.
stop." But in a hold, that wouldn't happen because you're landing on flat material, right? Unless you just paid out too much cable and then tried to hoist it back up. So what I would always do is instant we would slack a rope, because a rope there's four ropes on the crane, each rope's 60 grand, and it takes 24 hours to re-rope the whole crane. So you don't want to slack rope. But I would always I would always talk to the operator, and then I'd look at the PLC data. And the
Yes.
PLC would have a timestamp and tell me when it saw a slack rope and if there were multiple slack rope codes leading up to it. So that would tell me that he's done it or she's done it many times, and eventually it popped a shiv and now you've lost the cable off the shiv.
Yeah. Yeah.
So I'm using both, but context matters.
Oh yeah. Yeah. I mean, I ran into something similar in a steel plant on a crane. And there was very little anything between the crane and the operator, right?
Right.
So they were going, well, the cranes all see, the crane motors are continuous failing, and they're always failing on this at the beginning of this particular shift. So when we finished the investigation, we found out there was a specific operator on the shift before that was taught to bump.
Oh,
So on, off, on, off, on, off, on, off, on, off. And it's like, it's a wound rotor motor with virtually nothing in between, no protection from that.
that's right.
These were ancient
That's
systems.
across the line every single time.
Yep. It's now different. They actually replaced the entire crane structure, thanks to that operator.
Yeah, right. So that's so important, man.
Yeah.
And like we only got like 15 minutes, Howard. I know you and I
Oh yeah, we got to switch. Yeah, I could talk forever.
we go for days, but I want to just about that click, click, click. I repaired a ship hoist recently, and they asked me, well, how did the contactor inside went bad? And the contactor is what's receiving that voltage. It's 42 volts AC in this particular application. And I go, well, when I pulled that contactor apart, it was gone.
Yeah.
I said, every time you click and clack that button, you're making and breaking an arc.
Yep.
Constantly. And I said, and it erodes because they're silver contacts.
Exactly.
It erodes over time and eventually gets to the point where when you make contact, there's all these, the structure looks like this touching as opposed to like this touching. So you're in a constant high current state because you don't have any cross-sectional diameter to transfer that current.
And it makes it worse.
It makes it worse. All right.
Okay, so
transition. Let's talk a little bit about wind. We got 15 minutes. So I guess this is
that's enough time for this subject.
I know. So I was going to try to keep it simple.
Yep.
my first question is this: when we drive, like I've been to Midwest, you live out that area. Everybody's seen a wind turbine, right?
Yeah.
When you're driving and you're looking at a wind turbine, you see three main parts. You see
Tower,
the tower,
the nacelle,
the big box,
and the blades.
and
Yeah.
the blades.
Yeah.
So you already said
Sometimes a
one thing.
transformer at the bottom.
Yeah, and you already said one thing. I never heard that before.
The nacelle?
Nacelle. That's what they call that.
That's because we're all Trekkies. Just
Okay,
kidding.
gotcha.
No, it's literally that's what they call it. It's a nacelle.
So can you take us through the point of wind hitting the blade,
Okay.
how those blades interact? Because I know they pitch and yaw, right?
Yeah, and it depends on the manufacturer how they
Right.
configure that.
And then the transfer from the wind hitting the blade to how it may get to the infrastructure, and then how that may find its way to your home or your business.
Okay, I'll just describe off of one of the most common types, because there's a type 2, type 3, and type 5. So type 5 is there's only a handful of them in existence anywhere, and that's one where the blades are constantly pitching, and then you have a gearbox which adjusts speed so that the output is continuous.
And high, right?
Yeah, about 1800 RPM.
Makes sense.
And those are 13,000 volt systems. There's a handful of them that I'm aware of up in Canada. There's 10 of them total.
Right.
So there's not a lot of them. It's very complex. It's a mechanics way of adjusting speed.
Right. It's just like a variable geometry turbo.
Right. The next one is a synchronous type, which involves magnets. So it's usually referred to as a direct drive. A direct drive system, and that'll basically be blades come in, the outer hub turns, that outer hub is covered in so many magnets, the inner hub's stationary, that's got coils on it. So as the magnets pass that, it generates a voltage at a specific frequency that drops down to an inverter. I'm sorry, a converter, changes it to DC and then back to A, just like a drive. Right. You'll see them often in offshore. I think the Clipper was one of those at one point. So some of the old smaller ones. Those seem to be being looked at again as an option, especially for offshore. I'm involved with a few, and the toughest part of those is analyzing and figuring out faults. The most common, which make up about 96% of turbines, is called a doubly fed induction generator. But you can also have straight induction generators as part of that mix, and those make up a handful. So we'll go with the least first, and those ones are basically like an induction motor, and then they have a converter and inverter in the base of the tower. So we've been doing a lot of those recently. The generator is more robust, but the inverter has problems.
Right.
And then finally is called the DFIG, which doubly fed induction generator involves what amounts to a wound rotor motor or wound rotor generator. It looks like a wound rotor motor that has an inverter in parallel with the supply. The stator provides the output power. I'll cover that more in detail in a minute, but just how do I get stuff to that? Okay, so wind comes up towards the blades. Nowadays usually have LiDAR. So any type of air that has particulate or moisture in it is better. So they can detect wind gusts up to 100 meters out.
Did not know that.
Yeah. Plus the other thing is the reason why towers are usually twice the distance. If they fell over, they would be tip to tip. Has nothing to do with falling over and hitting tip to tip, right? It has everything to do with turbulence. Because if you see they're always in rows.
Yeah, they can affect each other.
They can affect each other in different wind positions. So you would have one on the end that's receiving all of the wind energy, and then turbulence hitting the other ones, and they become less efficient as you go down. So they all follow a power curve.
Oh, cool.
So you have such and such going on, and then as the wind comes in towards the blades, the system also has to have an idea. So you'll find a sensor in the middle of a wind farm that gives a general idea of the wind for the area, in addition to each tower having its own sensors. And that's because you don't really start to energize them until you hit. Some are a little bit better now, but the wind at 3.2 meters per second at about 80 meters up. So 80-meter wind is different than ground wind.
Sure.
It's very different. It's also one of the reasons why you won't generally see wind farms in cities or near cities, because of the turbulence from the buildings and so on. Okay, so you've gotten to this point. The wind then comes up against the blades. Now, depending on the manufacturer, they do different things based on wind gusts. One might start turning one of the blades ahead of the other ones, but the blades all turn.
Sure.
Okay. And they adjust the blades based upon the strength of the wind and the power to get a certain RPM on the output of the main shaft into the gearbox. So you'll have a main shaft. Most of them now have two bearings. Older ones might have one bearing, but two main bearings. And those are usually double roller each. And they usually are about, a small turbine knee high and the arrest waist high. And the giant ones now are taller than an average person. So those are critical, because if something goes wrong in maintaining those bearings, it's a minimum of $1.2 million to take the entire shaft and blades down,
Right.
and to replace the bearings. There are no split bearings. They attempted to do that. It did not go well.
Like
because
like a Babbitt bearing.
you don't use a Babbitt bearing on that, because it's handling the entire weight of the blades.
Oh yeah. And there's a higher coefficient of friction with a Babbitt bearing.
Yeah, don't even start me on that, because they're now talking about doing that in certain types of gearboxes on wind turbines, and all the repair guys are going, yay!
Yeah. Bring the money.
Manufacturers going cheaper, and the end users are going, oh man, are we going to have any working turbines? But
Right.
so anyways, I have that. Now that shaft is going to turn for, say, a 1.5 to a 2.6 or a 3.0 megawatt generator. Regardless, it's going to turn between 14 and 20 RPM. Can't go any faster, otherwise the tip speed on the blades will cause the blades to start to come apart. They start to fracture.
Which
So try to
anybody
keep them in
Google's
that
seen those on
teens
YouTube.
range. What's that?
You can watch those videos of those things coming apart on YouTube.
Yeah, it's
They
usually the
start,
same video, and the
they
good
blow
news,
up.
it's almost all in Europe. So we don't have that a lot here, thank
Yeah.
goodness. Because we actually take, and that's one of the things I chair, we actually take the wind standards from Europe in American Clean Power and modify them to meet our needs.
Right.
So they're reissued as an ACP standard, including structure, wind speeds, all that stuff is all handled slightly differently here.
Right.
Because of, we don't want those things to occur, right? We've had some, but they're rare.
Right.
Right. So considering we have 76,000 turbines in operation right now. So let's get back to that. So that shaft is turning and it's varying in speed, and it goes into the gearbox, into a planetary gear set. Otherwise, the forces involved would just tear apart the gearbox, right? So you go into a planetary gear set. Normally there's three planets. By the way, primary area of failure is between the planet and the ring gear. Okay, especially if they get loaded wrong or aligned incorrectly.
For all you gear nerds out there, that's called an annulus gear.
Yes. And then I've got two stages, a mid-speed and then a high-speed gear, which goes out, and it's either going to be output at around 1200 or around 1800. So either a 4-pole or 6-pole. Most common are 6, because slower speed is usually,
You need more poles.
Yeah, well, but also the slower speed tends to have less wear and tear on things like the gearbox and things like that. Some like the higher speeds because it allows for less expense. Basically, it's all trade-offs, right? So the output of that goes straight into a generator, and then the generator might turn, say a 6-pole generator might turn anywhere from 1145 to 1400 RPM. Okay. Now, if I change anywhere from 1200 exactly, I change the output frequency of the stator.
Right.
So in a doubly fed induction generator, I put a drive in parallel that feeds a wound rotor to change the air gap speed of the magnetic field.
Right.
So I might be turning at 1400 RPM, but the magnetic field cutting the stator is actually
Correcting.
turning at like 1208, 1211, something like that.
I was going to ask
All
that, how you compensate for such a big RPM
Yeah.
distance.
You do it electrically.
Yeah.
That means that on the output side of the generator, you have an almost pure sine wave. That's one of the reasons that defigs are so popular, is there's not a lot to have to manage as far as, if I convert it to DC and then invert it back to AC, it would be a PWM, and I have to deal with filtering all that, which is really expensive. Or I could do it this way, and then I've got a sine wave coming off that's normally filtered by the transformer in the tower. That transformer can be up tower or at the base of the tower.
Right.
So normal voltage off a tower, the most common is 690 volts. And that hits the transformer and it gets boosted up to either 35.5 or 69 kV. So
Did not know that.
yeah, and then that goes into the central distribution center in the site, right? Because the technically, depending on how you define it, and there's a whole thing we're in the middle of, that I could go on for hours on, having to do with a government agency that wants to change certain things with how towers are built, and how they're identifying a generator. They're saying the entire site is a generator. And then right, so and then the wind industry says, oh no, it's individual generators that make up the cell of a giant battery.
That makes up more sense to me.
And well, yeah, but it hits with international building code.
Oh, yeah. I don't know anything about that.
So any generator over a certain size has to meet certain criteria, which
Yeah.
would make it too expensive to build a wind farm, and under a certain size. So right now, the whole discussion has to do with the definition of what's a generator.
Right. I remember managing large generators running crushing and screening plants, and
Yeah,
the EPA was very interested in how many hours. Well, they were also diesel. How many hours we ran them? Were they prime? Were they, standby? Like it was a bunch of stuff we had to go through for that.
exactly. So I might have a site that has 120 turbines, all 1.5.
Hmm.
But when I'm into that large a platform, meaning that I'm sorry, platform's an individual tower, but that large of a site, you tend to take up multiple acres. And some of those sites, you start at one end, you drive down the gravel road at, oh, they say to do 30, but whatever speed you go at, it's about a half an hour or so to get to the other side.
Yeah, it's
So
pretty
we'll see
big.
turbines not turning way over there, or I'm sorry, we'll be at a turbine and it won't be turning because the winds drop too much, or
Right.
because they've stopped generating power from it, because they're being curtailed,
Right.
because they need to run a base load somewhere else for fuel reasons. So but we'll see a turbine turning way over there. So for testing the turbines, we'll run from this one to that one, and by the time we get over there, that one's shut down. Yeah, but
So then,
so
so then we got 2 minutes. So like,
yeah, so all of this is collected in a central location,
right.
all utility scale. If you're driving past a field of wind sites,
Hmm.
that does not power the homes right next to it. That actually gets boosted up to the grid itself, the not your local grid, but actually the grid. So it gets boosted up to usually upwards of 500 kilovolts. Yeah, 500,000 volts. Um,
I thought you were gonna say like 13.8 or something like that.
no, bulk grid to keep the conductors down. The great big lines that go
Oh,
across.
the big ones.
Yeah, so
Okay.
if I'm in my building here and I have a wind turbine like down the street, I'm not necessarily seeing an electron from there.
Right.
I'm that's boosting up. Now I might contract with the
Yeah.
owner of that
They're
site.
like a charge pump.
Yeah, yeah,
Yeah.
something like that.
Yeah. Yeah.
So yeah, so you have what's called base loads, which are all of your gas turbines and your coal-fired plants and your nuclear plants, and then you have the variable loads, which are solar, wind turbines, and so on. And then we use storage, battery storage, pumping storage, which is 95% of all storage, 94%, I'm sorry, 94% of all storage right now. Then you've got battery storage, which makes up some of that. And then you have other things like flywheel technologies that help with any variations, like wind variations and everything else because of that power curve, right?
Well, flywheel moves things through dead strokes, right?
Something like that. Well, I mean, these are actually little flywheel generators. So they'll be spun up to a specific speed. And
They
if
use the mass.
power drops, they start producing power back into the system. So they have a little VFD and a weight.
Yeah, right.
And
They use the
spin really
mass of
fast.
that flywheel to maintain the RPM.
Yeah.
Right.
And some of the larger ones are about 0.5 megawatt.
Right.
So I've been involved in designing some of those. So it's pretty cool stuff.
It is cool. You're gonna have to come back.
Yeah, to discuss the rest of the grid.
Finish this conversation. We went hard in on the motor stuff in the beginning, but that's what we do. And my question, Howard, are you going to be at Reliable Plant?
Yeah, of course. I'm speaking there.
I'll see you there, dude.
Yep, absolutely.
Well, look,
mean,
Howard,
it's not like it's just down the road if I happen to be in town.
I know. So I'll be on the CMMS panel with Greg, someone from Reliability X, Bennett Fitch, and somebody else.
Yeah, I don't even remember what I'm talking about.
I'm sure you know what you're talking about.
Yeah, well, I think I got two subjects I'm covering this year. One is how to calculate energy losses via vibration.
Love that.
Which I'm speaking on next week, as well as just electrical signature analysis. And then the other subject has to do with the energy and emissions KPI for reliability.
I love it.
Yeah. So, just why not tie things to the sea level?
Right. Well, dude, it's always a pleasure, Howard. I learn so much from you every time we talk, and I can't wait to chop it up and shoot the shit with you at RP in a couple months.
Yeah, absolutely. And it's not that far away.
It's not. So cool, brother. I greatly appreciate it. And we're so glad to be partnering with you. And we look forward to you sharing more of your knowledge with us and our community.
Great. Thank you very much.
Thank you, Howard. See you, man.